The next thing I want you to know is that we can construct a histogram of a probability distribution. So the histogram for a probability distribution is constructed the same way as a relative frequency distribution. Each outcome is represented on the number line, and above each outcome we erect a rectangle with width and height equal to the probability corresponding to that outcome. So let's go ahead and practice constructing a probability distribution. So I want to construct a histogram for the experiment in which a coin is tossed 5 times and the number of occurrences of heads is recorded. Okay? So I want to know how many ways could I get 0 heads if I flip a coin 5 times. Well, I'm sure from all the probability problems I had you guys do, we know that that's 1, but it's really the combination of 5 choose 0. That's going to give us 1, but it's 1 out of how many different possible outcomes are there? How many different ways are there for me to flip a coin 5 times? Well, that's going to be the size of our sample space, which is 2 to the 5th, which is 32, right? That's our sample space. So 2 to the 5th, so 132, which you could convert to a decimal if you wish, would be 0.03125. Or you can leave it as a fraction, right? When I'm constructing a relative frequency histogram, my y-axis can be fractions or it can be decimals. Remember, they're interchangeable. I'd probably keep it as fractions because it's a lot nicer looking than this, in my opinion. So next, I want to know the probability of how many different ways can I just get 1 head. So that's going to be the combination of 5 choose 1 over 2 to the 5th. I get 5 out of 32, which is 0.15625. For the ways I could get 2 heads, that's going to be 5 choose 2, which is 2 to the 5th. So I get 10 over 32, which is 0.3125, right? And remember that these numbers right here, these follow a row of Pascal's triangle. So I bet you can already tell me what my next 3 numerators are going to be, but let's do the combinations to find out. So if I have a combination of 5 choose 3 over 2 to the 5th, that's going to be, you guessed it, 10 over 32, which is again 0.3125. So it looks like our graph is going to be symmetrical. Let's take a look at that. So I have 5 choose 4 over 2 to the 5th, which is 5 over 32, so again 0.15625. And I have 5 choose 5. There's only one way when you flip a coin to get all 5 heads, right? Over 2 to the 5th, which is 32. And that's going to give you 0.03125. So we can see our graph is going to look symmetrical. That's really an important property. Here it is so we can check your answers. So let's go ahead and construct a probability distribution. Okay, so I'm going to have 1/32. So over here is our probability, also known as the relative frequency of those occurring. Here's our number of heads. Here's our title would be probability of getting heads. I've got 0. You could get no heads. 1, 2, 3, 4, 5. 1/3, 3, 30 seconds. 4, 5, 30 seconds. 7, 30 seconds. I'm not leaving all of these because fractions are tiny. 9, 30 seconds. And here we have 11, 30 seconds. So let's go ahead and draw this graph. So the probability of getting 0 heads is just 1 out of 32. That was a terrible. Let's try that again. 1 out of 32. The probability of getting 1 head is 5 out of 32. 2 heads was 10 out of 32. I've had too much coffee, y'all. Probability of getting 3 heads is 10 out of 32. And again, our graph is symmetrical. Look at that. So what I mean by our graph is symmetrical, it's kind of like squares are symmetrical, butterflies are symmetrical. If I draw a line down the middle and fold it in half, it looks the same. So here we have a more professionally done graph of our probability distribution. So when I'm given a histogram, I can look at the probability of an event. So in a histogram of a probability distribution, the probability of an event is the sum of the areas in the rectangles corresponding to the outcomes in the event. For example, if I wanted to know the probability of getting at least 3 heads for our previous sample, it'd be shaded in blue. So it'd be 10 30-seconds, plus, because this was 10 30-seconds, right? Plus 5 30-seconds from here, plus 1 30-second from here. That'd give us 16 30-seconds, which is a half or 50%, right? I can use this graph to calculate the probability of an event.